Okay, sorry this is gonna be a bit of a late upload. I had a bunch of other stuff to get through before recording this. But today we're gonna be going over um, base 10 to hexadecimal and then hexadecimal to binary. So base 10, as we covered in the last video, the binary video. Base 10 is just one. Yeah, it's hold on, let me fix that. It's just 1, 2, 3, da, 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 all the way through 9, and then you graduate to the 10s. And then with binary, you have, well, first I guess you start off with 0. With binary, you have 0, 1, and then you graduate to 10. Because each slot in binary represents powers of 2 instead of powers of 10. So a quick recap of that is that in base 10, the first slot is powers of 10 to the 0th, second slot is 10 to the first, second or third slot is 10 to the second. So you have the 1s, the 10s, and the 100s. That's different compared to binary, as binary has 2 to the 0th, 2 to the, ooh, that's really off, 2 to the first, 2 to the second, so on. So with this you have the 1s, the 2s, the 4s, I guess I probably, oh no. Oh, but that's fine. I was on the wrong layer. Oops, daisy. So with this, it'd be 2 to the 3rd, 2 to the 4th, and that would be your 8s, and then that would be your 16s, and so on and so on and so on. It just keeps going up by powers of 2. Hexadecimal is the same thing, but it is, instead of powers of 10 or powers of 2, it's powers of 16. So it goes 16 to the 0th, 16 to the first, 16 to the second, and that should be about all you'll use. It would be the 1s, the 16s, and the 256s. Now counting in hexadecimal is a little different than counting in base 10, because once you hit 10, you can't write 10, because 10 is 16. You have 1 16 and 0 1s left over. So counting in hexadecimal is 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E. Ooh, good lord. Oh, wait, no, I ordered that horribly. Hold on, we'll go through it. We'll get it right. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 10, 11, 12, so on. And then once you get to, so A is 10, B is 11, C is 12, D, I matched them all up here. A 10, B 11, C 12, D 13, E 14, F 15, and then 10 is 16, because as we saw over here, 16 is 116 and 0 1s, making it 1 0. Now let's say we were going to write something like 27. So 27, breaking it down, how many 16s do we need? 1. So 20. Actually, I'll get red for base 10. So 27 equals, in binary, 116 So then 27 minus 16 is what? 11. So we go up here, 11, B. So 27 in binary is 1B. Now, when we move up to something like 32, 32 equals... So what 32, how many 16s do you need for 32? 32 divided by 16 is 2. So you need 2 16s, and then you have nothing left over. So that would mean 32 is 20 in hexadecimal. Now that's all nice. But when is hexadecimal going to ever really be useful, except just displaying numbers in a more compact format? Well, when you're converting from binary to... Whoops. There we go. When you're converting from binary, or no, when you're converting from base 10 to binary, it can be a little difficult to but gauge what's going to happen. But converting from base 10 to hexadecimal to binary is really easy. And I will show you why, because converting hexadecimal to binary is super easy. Now, when you are writing binary, you should try and keep things in groups of 4. So like 0, 0, or no. 1, 2, 3, 4, comma, 1, 2, 3, 4. Something like that. So let's say we wanted to write, I don't know, 33. So 1, 2, 4, 8, 16. Let's do 35. So 1, 2, 4, 8, 16, 32. So 132. What did I say? 35? Okay. So 132, 0 16s, 0 8s, 0 4s, 1 2, and 1 1. That's 32, or no, 35 in binary. See how that kind of, you had to go 1, 2, 4, 8, 16, 32. There you go. Converting from hexadecimal is much easier because what you do is you take your 35, convert it to hexadecimal. 35 in hexadecimal would be 23 because you have 2 16s, 32. 35 minus 32 is 3. That's where you get, here I'll write a little, equals 35. Now, what you can do with this is each of these numbers, the 2 and the 3, corresponds up here. So the 2, I'll grab like pink. So the 2 represents these. And then grab like a light blue. The 3 represents these. So now what you would do is you would take the 2. What's 2 in binary? 2. And then 0, 0, 0. What's 3 in binary? 1, 1, 0, 0. So look at that. Converting from hexadecimal to binary is super easy. Even if you have something like what do we go with? Like, if you have A, E. I have no idea what that is in base 10. But I guess we'll figure that out real quick. So A is 10. I should have kept that written down. But ugh. Sorry. A is 10, so that means there's 10 16s. So it's 160 plus E, which is 14. So 160 plus 14 is 174. So 174. That would be a pain to convert into binary. But with our method up here, all we gotta do is take our pink and our light blue and translate them up to here, which is as simple as A is 10. So 10 in binary is 1, 8 and 1, 2. Boom. 10 in binary. That's done. Sorry, I'm a little under the weather. But E is, like I mentioned, 14. 14 in binary is an 8. And then what's left after that? 6. So it would be a 4. What's left after that? 2, 2, 0. Boom. Look at that. 174 in binary using hexadecimal. I like to use this method a lot more. I know most teachers will as well. And if you do anything with binary or hexadecimal in the future, this is probably your easiest way of converting to them. Binary is really useful to know. It's used in a lot of codes. It's also used in coding because it's how computers count. Hexadecimal is very useful. It's a compact way to store numbers. It's a compact way to store numbers easily. And then it's useful for converting base 10 to binary. It's also just kind of fun to have in your pocket as a skill. So yeah, thanks for stopping by. Happy studying, and bye-bye.